Hi, one of the YouTubers I follow is Kevin McClear, um, and he does a lot of cool robot projects. And he's working on this thing called a Pico Crab, and pretty cool project. He's showed the beginnings of it. We'll probably get the finish of it later, but he also asked for people to let him know about walking robots that they had done. So it's been quite a while, but I figured I hadn't documented on YouTube what we did back in 2016. I was the volunteer leader of a teen club at a public library called the Imagineering Club, and uh, started in 2015, but we went through all the basics and everything on Arduino. It was mostly Arduino and some 3D printing, and had them doing some designing in CAD and everything. And we uh, it was a good group of teenagers and a lot of interest and everything. So we had done a few other projects, but we decided we wanted to do somebody brought up a walking robot that they found a video online with. Um, so we looked around and everything, and there's several back in 2016. There was several videos and everything, but not a whole lot of documentation on them. And of course, now you got all kind of walking robots and everything. And but we kind of said, well, let's use some ideas that we see and design our own and everything. So that's what we did. Uh, Here's the final one of the final robots. It's a it's a eight. I think it's a AT Mega. I forget the. It was the. It's the. It's not a. Uh, I'll show you later, but it's not a regular Uno robot in there. It's a different uh, controller that's discontinued, but used the Arduino framework and everything. So uh, we actually, like I said, when we were designing this, I said, well, if we're going to design this from scratch, we should probably document what we were doing. So we were taking pictures along the way, and after we finished the robot, we spent a couple weeks putting together Instructable about it. So we actually got the Instructable here, and it's like I said, it's a um, here's the group of team. There's several other people in the group. This when we took this picture, there happened to be no girls there, but we actually had two girls in our Imagineering club as well, and so it was about a dozen people total, and they everybody contributed and best ways they could, and we had a couple kids that had picked up the Arduino coding pretty good, and we were you know cutting them loose. Of course, they certainly had help from me, but I let them do most of this part, like the feet and everything. I was thinking just flat feet or something, and they said, "Oh, they found one that had feet like that." I said, "Well, how do you draw feet like that?" I says, and so we were working on it, and they had already learned how to measure with calipers and everything, so they had an idea what to do. So they measured their servos and figured out how to get the servos in there and the servo brackets. We went through several iterations. Nothing comes out perfect the first time. I gave them a free hand, and they were pretty good at what they were doing. I mean, I gave them guidance, but I certainly didn't do the heavy lifting on this. I let them do on the design of the robot and what they came up with and everything. And it was kind of cool. So here's a short video of it walking. Um, we got the echo sounder on there as well. So it's called Walk Avoid is the code that we got in there right now. Maybe it'll run. Come on. There we go. So it's nothing fancy, but you got to remember this is teens back in 2016. So I thought it was kind of impressive. This is where it reverses and turns. And then once it does about 90 degrees, it'll start forward again. So that's the end of that one. Like I said, it was a bunch of teens that did it. And like I said, we were taking photos along the way. Um, so we laid out our thing. This is the controller we use. It's the Micro Magician. I think it had the 168, the 18 mega, you know, I think it's 328, you know, for the Arduino Uno, but I think it was the 168 or something like that it was called. But the thing was, is it had the pins, it had servo connections on the side, male headers with power and ground as well. So you could plug your servos into it without any wiring. So we were able to use it just the way it was. So that was kind of cool. We were able to use that, and like I said, we had an echo sounder, and we had back then you could pick up these round power banks for $1 or two with the what do they call 15 something 18 360s or whatever batteries in them, and it would give you 5 volts out, you know, power bank, and nice design, and we were able to incorporate it where you just set it right down inside there. But anyhow, I'm going to link to this Instructable so that you guys can see it. But back then, 2016, we didn't have Fusion 360. We were doing our CAD in something called Design Spark Mechanical. It was a nice program for the time and everything, and but Fusion 360 was way above that. So when it came out, we switched over to using that. But in 2016, Fusion 360 wasn't out and about, I don't think yet. But it uses the 4, and we're just using the small plastic geared servos, and they work fine. Um, and we got it here. Just did a pretty thorough. They took a bunch of pictures, and they wrote it up, and then I'm not very good at doing editing or anything. My wife is a school teacher, so I let her edit some of this code. She doesn't know anything about technology, but she knows about grammar, so the grammar ended up fairly good in it. I think I might have went back and checked some stuff, so if any mistakes in there in grammar are mine, but anyhow, we did it, and just talked about how to calibrate the servos and everything, and just about everything for how to do it. And then for programming, so like I said, there wasn't a whole lot of documentation out there, but the one code that we did find was like 500 or 600 lines of code. And this was a class for trying to teach these guys coding. So I could barely, I had probably only been a hobby coder for a year or two at that time, and I barely was able to figure out what they were doing in their 600 lines of code. But anyhow, we were able to glean something out of it, and I said, well, let's start over. Let's see what we can get out of this code, and figure out what we do. But one of the things we saw in there was they had this thing called frame, and um, each step finished at a certain spot. So you went from one frame to another, and it was just servo positions basically. It was bringing, getting the servo into a position, and then you'd start the next frame and go towards it. So I think one of the reasons that their code was so long was that they bring up the code that I have here. So was that they were tracking their coding, by milliseconds or whatever, and doing that. and using the regular servo library. Somewhere along the way, early on in learning about this, I came across this very speed servo from a guy named Corman, or a screen named Corman, and it, it allowed you to go from one position to another, or go to a position. You gave the position that you wanted your servo to be in, but you put a time thing on it, so it would do it over a certain period of time or speed. So that way we didn't have to worry about millisecond by millisecond. We just had to set our frames where we wanted them, And Kevin also he was showing his code that he was going to use for this. It was a refactored code from 2018 for another robot, but it was like 800 lines of MicroPython. And I think that you could probably come up with a function or something in MicroPython where you could do similar, where you could move your servo, over a certain period of time, and probably with some, timers or something in there, and probably get a class or something for it is probably what you'd want to do. But like I say, the class was in the background of ours. We had it pre-made servo. So our walking thing, we just came up with these frames, and like I said, we only had 4 servos, where Kevin's going to have 8 in his crab walker robot. But I think it would work out close to the same, where you just if you had like something that would move to a certain position over like we're moving, I think, in 3/4 of a second, 750 millisecond time intervals here is how we're doing it. And so this is the position in degrees that we're going to. And when it finishes that move, it just goes down to the next one, into the next one, into the next one. And then it goes back up, and you're ready to start a new walking frame. But we were able to do that. And then for the turn, we had another set that, we did that to move it. And this was probably the turn where it does that backing up and turning it 90 degrees. When we were programming it, we had, lots of probably like 4 or 5 different moves, forward turn, right turn, left turn, all that, So you would have to, each one of them would be a set of frames, but it, seems like that you could, copy them, each step and everything. But it turned out really good. And then we just had a function to run these frames down here. And we're just moving it at a servo speed. And this one, like I said, we had, and this includes the echo thing. So check your echo, and if it was too close, then it would do the turn. It would either go forward, or it would do the turn in reverse sequence. So we were able to do this in less than 100 lines of Arduino code. And I think that my students, I probably did a lot of the thinking or whatever on this, but they contributed to it, and I made sure they were typing it and understanding what it was doing and everything. And like you say, we had some calibration, getting the servos calibrated so the robot was standing up and everything. And I let them do a lot of that. Once they understood about how to get it into the frames, they said, "Oh, we can just do a frame for standing up," and they were doing it. So anyhow, like I say, the Arduino code that we looked at was 500 or 600 lines. I knew they would probably eyes would glaze over and not pay attention to what it was doing, and it would just be a toy that we put together. But by doing it this way, I think they were able to get what they were doing. Anyhow, let's go down to the bottom. We ended up making a dozen of these, I think, for all the kids. Yeah, I think there was 11 here, and probably was a 12th one somewhere around. I think we made a dozen of them, and they were all working for the different kids, and they got to choose the color that they want. Some of them went with different color feet and everything, and but they were all happy with it, and I think they all learned something. It was a 6-month project for us between from the conception to the design to the coding to the assembly, and then we spent, like I said, probably 2 or 3 weeks putting together the documentation to put up this instructable. But that club, it started in 2015 and ended in let me get myself out of the way here. Ended in 2018, so it had about a 3-year run, and they just the teens got older and got interested in the opposite sex and cars and everything like that. So it just kind of died away, and we didn't have a new group coming in, so we just decided to let it go. One cool thing is a couple years after we designed that, I guess somebody came up with all these biped robots that they had found on the internet, and they came up with this open source robot poster, and we actually made it onto the poster. Somebody added us on there. Like I said, this was Zowie and all those. Otto, I think, is still going big and everything. And I know that the code's got a lot better. You got dancing robots, and they can move a lot faster and a lot more stable. But we were kind of cool. So this Bridgeville, I think, was the one that was available back then. I don't know if that's the one that had all the code or not, but one of these robots did. I think the original was this Bob or something, so that's why we called it IC for Imagineering Club. That was the name of our club, and it was IC Bob. But you can see we've done different projects. We started out with 3D printing, just making keychains. We did a NeoPixel night light, we called it, and the club started by, we got together to see if there was any interest, and we assembled 25 of these spider bots one night, and we had 2-people teams, and we had 50 people come to the library to assemble that. And out of that group, we ended up with a dozen or so that came quite regularly for 3 years. But we did lots of projects, but it just came to an end. Anyhow, that's what I got to show, and just wanted to let Kevin know that there's others out there that have done it, and you can actually make it simple enough that teenagers can get the grasp of it. You don't necessarily need 800 lines of code. Anyhow, thanks for watching. Bye.